Okay, so this video is going to cover what we call the fundamental identities. And in the intro, we looked at some of these that you probably are already familiar with, just didn't know they were called identities. You got these inverse identities, and you got the tangent cotangent that can be gotten from the sine divided by the cosine, or the cosine divided by the sine. These are things you probably already looked at from the unit circle, and they're considered some of the fundamental identities. These are pretty basic, and this is not so much memorization, but just kind of being familiar with your unit circle. And the more you understand about your unit circle and how those things work, the more these fundamental identities will just be something that you can kind of look at your unit circle and get it right without having to worry about memorization so much. So let's take a look at the rest of the fundamental identities. These cover, and this is the good thing, these are the ones that you don't have to rely on memorization so much. You can look at your unit circle, you can kind of work them out if you need them. And these are going to do 80–90% of the work for you in all the problems that we got with identities. So take that to heart. This is all good stuff. And I think these next ones, don't let them freak out. They're not that hard. So let's take a look at them. So get rid of that. And here we go. Let's talk about these Pythagorean identities before we get to the negative angle ones. Let's take a look at these Pythagorean. Sine squared plus cosine squared equals 1. This should make some sense if you're looking at your unit circle. You're really hastily drawn. But remember, your x is your cosine, right? Right? So this distance here is your cosine, and this distance here is your sine, and the unit circle is called the unit circle because your radius is always a 1. So it makes sense that cosine squared plus sine squared equals 1 squared. So we get sine squared plus cosine squared is always 1. Okay, so there you go. This comes straight from the unit circle. It's called a Pythagorean identity, obviously, because we're using the Pythagorean theorem to just put that together. These remaining two actually derive themselves from, and what you can do is just take this and multiply it through by either the tangent. I believe that's what you do. But we can figure that out, and you can actually derive these from the original. Okay, so these aren't things that you have to worry about forgetting and not understanding. Straight off the unit circle. Likewise, let's look at these negative angle ones. And again, just by looking at your unit circle, you can say, okay, since the sine is a y-axis issue, right? If you've got a negative angle over here, right, then it's just going to be the negative of the sine. That's pretty straightforward. And you can look at some examples on the unit circle, right? If I have a negative angle, then my sine is going to be negative, right? That makes sense. And you can kind of work that out just by looking at your unit circle. Likewise, if your cosine, and of course these are inverse, so they're going to be exactly the same, right? The cosecant is always going to do what the sine does. Likewise, secant is going to do what the cosine does. The cosine, on the other hand, when you're dealt a negative angle, since the cosine is still just this distance here, right? It doesn't matter whether the angle is positive or negative. It's still the same distance. It'll still either be positive when it's positive, negative when it's negative. So it doesn't change. Okay? And you can kind of work the same thing out for the tangent and the cotangent. They're basically a combination of the sine and the cosine. So they're going to behave much like the sine does because sine introduces that negative. So these can all be worked out pretty straightforwardly. And this isn't something you have to memorize, just kind of be aware of, and then know that, hey, if I've got a sine or a cosine of a negative angle, I can convert that either to this or this, and it might clean up my identity pretty quick. These Pythagorean identities, They come up a lot in working these identity problems. In fact, a large number of the identity problems have you kind of work one side or the other into one of these Pythagorean identities, because you can just imagine that we can take something like 1 plus cotangent squared, rewrite that as cosecant squared, then maybe write cosecant in terms of sine or cosine, and we just simplify things up a whole lot. So we're going to introduce some more identities, and then a little later we'll just go through and we'll start working some of these problems, and you'll see that they're really not that bad, and they tend to fall into a particular pattern. There's maybe 2 or 3 different patterns of how you solve these things out, and that's really all there is to it. So I hope you all doing well.